This is the one example for the Thevenin's network or a complex network. So we'll see how to solve the complex network by replacing this Thevenin's equivalent circuit. The question for this network is as follows. For the circuit shown in figure, find the Thevenin equivalent circuit with respect to terminals AB and also determine the current through AB. So this is the one question for the complex network. This is the AC source. These are the two AC source, 5 ohm and inductor of J2, and there is a capacitor here. These are the two pure resistors. We have to replace this entire circuit first with the Thevenin's equivalent circuit with respect to these two terminals. With respect to these two terminals. The steps is as follows. First, we have to determine the open circuit voltage or Thevenin's voltage between these two terminals AB. Next, impedance between these two terminals by removing this 4 ohm resistors. So first step, we will solve for the first step. When we remove this load RL, circuit will be looks like this. A, B. This is the potential with respect to A and potential with respect to B. There is a one voltage source 50. Then this is the reference voltage. You call it as a VA, that is the drop across inductor is the voltage at this point A with respect to this reference voltage. How to determine? You determine the current in this loop, then that you call it as I1 into J2. So that is the drop here. I am going to call it as a VA. The current flowing in this network is 50 volts divided by 5 plus J2, and the drop across this is J2. That is, convert this into polar form because division operation comes better you keep it in a polar form. 100 to this J is a 90 degree. 5 plus J2, its polar form is 5.385 with phase angle. Then after simplification, this is the VA, 18.57. Similarly, we will determine the VB. What about VB? The drop across this minus J2, that is the capacitor. We will find out this mesh current or loop current around this loop. Then into this minus J2, that is a 5090 divided by 2 minus J2, that is the current. And drop across this is a minus J2. This is the voltage after simplifying. So convert this rectangular to polar, then simplify it. Then voltage is a difference between these two, VA minus VB. So finally we convert that into this will be the your in the polar form, rectangular form. Then you convert that into a polar form. So these things directly, most of the calculators will support directly. We can subtract in polar form, and finally this is the answer. This is the VAV. Next step is determine the Thevenin's impedance. Remove this resistor, and here voltage sources, short circuit these voltage sources. Next step is determine the Thevenin's impedance between AB. Shortened here, and these two are in parallel, and these two are in parallel. Finally, these two are in series. This entire impedance and this entire impedance is series. That is 5 into J2 divided by 5 plus J2 plus 2 into minus J2, 2 minus J2. Convert it to polar form because multiplication comes better in a polar form. Then calculator directly you can subtract here and impedance convert into a rectangular form. This is the impedance with respect to terminals AB. Next is redraw the circuit. This is the voltage source and current. This is the impedance 1.689. Next, connect that resistor 4 ohm. Then I is this open circuit voltage divided by this AB. Z Thevenin impedance, that is a ZTH 1.689 plus this 4 ohm. Yes, not a AB, it's the Z Thevenin actually. It is a Z Thevenin plus this 4 ohm. It is a polar form. This is a rectangular. Division operations I have to do. Convert this into polar form. Finally, this current flowing through this IX is a 3.43 with angle minus 163. So in this way, we can calculate, replace the Thevenin equivalent, then determine the equivalent circuit.